Welcome to G Fun Facts Online. We often see the stars as distant, peaceful lights, but the universe is far more dramatic. In the silent darkness of space, stars regularly turn cannibal, devouring their own planets in a fiery feast. This isn't science fiction. It's a predictable and common chapter in the life of many star systems. And one day, it will be the final chapter for our own. Today, we're exploring the epic saga of stellar cannibalism, a story written in the chemical makeup of stars and the ghostly glow of distant nebulae. Let's dive into the life and death of a star, a journey that inevitably leads to a cosmic meal. Stars are born from immense cold clouds of gas and dust that collapse under their own weight. As the core of this collapsing cloud heats up, nuclear fusion ignites, and a star is born. For billions of years, it lives in a stable phase called the main sequence, fusing hydrogen into helium. This process releases enormous energy, creating an outward pressure that perfectly balances the inward crush of gravity. Our Sun is a middle-aged star, about 4.6 billion years into its main sequence life. It's the source of stability in our solar system, but this calm won't last. In another 5 billion years, the hydrogen fuel in the Sun's core will run out. Without the outward push from fusion, the core will contract and heat up. This new, intense heat will ignite the shell of hydrogen surrounding the core, and this is where things get dramatic. The star's outer layers will expand to an incredible degree, transforming it into a red giant. A red giant can swell to be hundreds, even thousands of times its original size. For our Sun, this expansion will be so vast that its fiery edge will stretch past the orbits of Mercury, Venus, and very possibly Earth. Any planet in its path is doomed. So, how does a planet actually get eaten? It's not a quick gulp, but a slow, brutal process. It begins with what's called the initial drag. As the star's outer atmosphere, its envelope, expands, it reaches the innermost planets. A planet that once orbited in a near-perfect vacuum now finds itself pushing through a thin, but increasingly dense, cloud of superheated gas. This creates a drag force, much like air resistance on a moving car. This drag robs the planet of its orbital energy, causing its orbit to decay. It begins a slow, inevitable spiral inwards, closer and closer to its parent star. As the planet spirals closer, a more powerful force takes over: gravity. The star's immense gravitational pull is stronger on the side of the planet facing it than on the far side. This difference creates colossal tidal forces that stretch and deform the planet. This is similar to how our moon creates tides on Earth, but amplified to a world-shattering degree. Eventually, the planet crosses a critical boundary known as its Roche lobe. Past this point, the star's gravity overwhelms the planet's own, and the tidal forces become strong enough to rip the planet apart. This process, called tidal disruption, tears the planet's material away, which then falls onto the star. For a denser planet that might survive this tidal shredding, or for the core of a disrupted gas giant, the end comes in a final, fiery plunge. The planet is consumed by the star's roiling, turbulent plasma. Its convective envelope, all its elements are vaporized and mixed into the stellar material. The immense energy from the planet's orbital motion is transferred to the star. This can cause the star to temporarily spin faster and brighten dramatically, a final, fleeting flare from a dying world. For decades, the evidence for this cosmic feast was circumstantial. Astronomers were like detectives, piecing together clues. One of the most powerful clues is found in a star's chemical fingerprint. When a star swallows a rocky planet, the planet's elements are dredged up and mixed into the star's outer layers. We can detect these changes using spectroscopy, which is the analysis of starlight. A key piece of evidence is the element lithium. Lithium is very fragile and is easily destroyed inside stars like our Sun. This means older stars should have very little of it. However, rocky planets, like Earth, are rich in lithium. So, when a star engulfs a planet, it gets a sudden, fresh dump of lithium into its atmosphere. Astronomers have found many older stars with suspiciously high levels of lithium, making them strong candidates for recent planetary consumption. It's not just lithium. Other elements common in rocky planets, like iron, silicon, and aluminum, can also appear in unusually high amounts. By comparing a star's chemical makeup to that of its siblings, stars born from the same initial cloud of gas and dust, astronomers can spot these anomalies. In fact, recent studies of these conatal star pairs suggest that as many as 1 in 12 stars show evidence of having ingested planetary material. Another clue comes from the gravitational chaos an engulfment event leaves behind. When an inner planet is destroyed, it disrupts the delicate gravitational balance of the entire system. The orbits of the remaining outer planets can be violently perturbed, flinging them into strange, highly elliptical or tilted paths. Finding a giant planet in a bizarre orbit around a star that also shows chemical signs of a meal is a strong indicator of a past engulfment. The destruction of a planet can also create a disk of dust and debris around the star. We can detect this debris through the infrared light it emits. Old stars should have cleared out any dust from their formation long ago, so finding a dusty disk around a mature star is another big red flag for stellar cannibalism. For years, this was all indirect evidence, but in 2023, that changed. Astronomers announced the first ever direct observation of a star caught in the act of swallowing a planet. The event was named ZTFS-LRN 2020, located about 12,000 light-years away. It started with a sudden brightening. Follow-up observations from multiple telescopes revealed what scientists called a, quote, a 1-2 punch of evidence. First, they saw a long-lasting glow of infrared light. This was interpreted as the doomed planet pulling hot gas from the star's surface as it spiraled inward. This gas then cooled to form a cloud of dust. This was followed by a brilliant flash of visible light. This was the final, cataclysmic moment when the planet plunged into the star. The energy released caused the star to swell up and become hundreds of times brighter for a short period. This groundbreaking observation was the smoking gun. It provided the first direct proof of planetary engulfment and gave astronomers a clear template of what to look for in the future. The act of consuming a planet isn't a one-sided affair. The star itself is also profoundly changed. The angular momentum from the orbiting planet is transferred to the star, causing it to spin faster. The influx of new material can trigger changes in the star's magnetic activity, leading to more frequent and powerful stellar flares. And as we saw with ZTFS-LRN 2020, the star gets a temporary boost in brightness. Meanwhile, the rest of the planetary system is thrown into chaos. The stable, clockwork-like orbits are shattered. Surviving planets can be knocked into new, unstable paths. Some might even be ejected from the system entirely, doomed to wander interstellar space as rogue planets. Others could be set on a collision course with each other or with the star itself. It's a complete gravitational reset. This story of stellar cannibalism isn't just about distant stars. It is a direct preview of our own solar system's ultimate fate. In about 5 billion years, when our sun runs out of hydrogen, it will begin its transformation into a red giant. As it swells, it will mercilessly consume the inner planets. Mercury and Venus will be the first to go, their rocky bodies vaporized, and their atoms assimilated into the sun's fiery plasma. Earth's fate is less certain, but the outlook is bleak. Some models suggest Earth's orbit might widen slightly as the sun loses mass during its expansion, but it's highly likely our planet will not escape. We are right on the edge, and even if Earth miraculously survived being physically engulfed, it would be an unrecognizable, hellish world. The intense heat from the bloated sun would have boiled our oceans and stripped away our atmosphere centuries before, leaving a scorched, lifeless rock. But as the inner solar system becomes a furnace, the outer reaches might experience a brief golden age. The habitable zone, the region where liquid water can exist, will shift outwards. The icy moons of Jupiter and Saturn, like Europa and Enceladus, which are currently frozen solid, may thaw out. They could develop vast, liquid water oceans under their icy shells. For a short time, these newly warmed worlds could become potential oases for life. Even distant, frozen dwarf planets like Pluto could experience a brief, tropical climate. This new era of potential habitability will be fleeting. After about 1 billion years as a red giant, the Sun will shed its outer layers. This will create a beautiful, glowing structure called a planetary nebula. At the center will be the Sun's dead core, a white dwarf, a hot, dense, Earth-sized remnant of a once mighty star. The remaining planets, if any survive the chaos, will continue to orbit this stellar corpse in the cold and the dark. The phenomenon of stellar cannibalism is a powerful reminder that the universe is constantly in flux. It's a process that is both incredibly destructive and strangely creative. It's a cosmic recycling program that enriches stars with new elements and completely reshapes planetary systems. The very elements forged in stars and scattered by their deaths, the atoms that make up our world and our bodies, are a testament to this endless cycle of creation and destruction. As we continue to peer into the depths of space, we're not just witnessing the death of distant worlds. We are also glimpsing the far-off future of our own. The story of the stars is our story, and in their fiery deaths, we can read the final chapter of our own cosmic tale.